In this video, we'll be learning about lesson number 5 for third quarter in Physics 2. So why is it important to control electricity? So for the past lessons, we already learned that we can have our source of electricity through various types of sources such as batteries. We produced also electricity from generators and many other sources of electricity. But how can we control it knowing that we already have now our source of electricity? So to answer that question, we need to answer this question on how can we control electricity. By knowing how can we control it, it becomes clear that how is it important to control electricity. So let's proceed. So when beginning to explore the world of electricity and electronics, it's vital to start by understanding basics of voltage. We have here three basic electrical quantities such as voltage, amps, and ohms. As you can see in the diagram, there's the voltage, volt, with the color yellow, pushing this amp, and while this ohm with the color red, restricting the movement of the amps. By seeing through this picture, we can know that we can identify that voltage is the one that gives amps a push. So that tells us that voltage is the one giving this ampere movement. So without voltage, there's no movement of amp. And what is this amp? This amp is known as your electrons. So we can control the flow of electrons, also known as amp, through what we call a resistance with a unit of measurement of ohms. We cannot see them in actual reality, but we know that there's a flow of current if we are to use measuring instruments and of course devices that consumes electricity. And nowadays, these basic three electrical quantities plays a big role in our day-to-day living. So, by studying Ohm's law and Joules law, we shall find that a small number of underlying principles describe all of them and that electricity are more common you have ever imagined. This critical thinking and problem solving skills will help us become the individuals we aspire as reflected in the program educational objectives. So, at the end of this lesson, we should be able to number one, analyze how the context of current, resistance, and electromotive force related to one another through Ohm's law. Actualize the sense of responsibility and honesty in doing experiments involving current, resistance, and electromotive force. Conduct an experiment using the Ohm's law equation to compare experimental and theoretical data from current, resistance, and electromotive force measurements. So let's start first with how electricity is defined. We define electricity as the movement of electrons. When there's a movement of electrons, we create charge. Okay? We can harness electricity to perform work. For example, your light bulb, no? Your stereo, your phone, these are all devices that harnesses electricity to perform work. And when there's a movement of electrons, then basically there's movement of electrons, there's electricity. So there are three basic quantities. We have voltage. So how do we define voltage? It's the difference between in charge between 2 points. So there's positive and negative. One is with value and one is zero. Current is as which the rate at which charge is flowing, meaning how fast does it move. And resistance is the tendency of a material to resist the flow of charge. So, in studying Ohm's law, we also need to identify what is a circuit. When you say circuit, it's a closed loop that allows charge to move from one place to another. So, in order to continue working with Ohm's law, we can use a circuit to perform a work using electricity. So, George Simon Ohm, a German physicist and mathematician, began his research with a new electrochemical cell invented by Italian scientist Alessandro Volta. That electrochemical cell was used to perform his creation, wherein George Simon Ohm found that there's a direct proportionality between potential difference or voltage applied across a conductor and the resultant electric current. This relationship is known today as your Ohm's law. So what is this Ohm's law? It involves three basic electrical quantities. First is your voltage. For the voltage is the amount of potential energy between 2 points in a circuit. So one point has more charge than the other. The difference in charge between 2 points is called voltage. So it is the capability of the voltage on how it will impart 1 joule of energy per coulomb of charge that passes through it. So it was named after the Italian physicist Alessandro Volta, who first invented the known as the first chemical battery. So we use capital letter V to write the symbol for voltage and the unit V also for volts. There are also other terms for voltage such as electromotive force and potential difference. Also, we can compare voltage for what we call water tank analogy. So in a water tank, for example, this water is being pulled down through the force of gravity. So the higher the water, the higher its height, the higher the potential energy, and that potential energy can create pressure. So the higher the water is, the higher the pressure it can get, meaning the higher the voltage, the higher the pressure. Okay? Next. So as this water goes down and being decreased in that container, the voltage or the pressure itself also decreases. Thereby, we can compare it or use an analogy to it as voltage. So that is why when you use components that use batteries, they go dimmer. For example, your flashlight. You have a flashlight, and these batteries get slow. The flashlight gets dimmer as the batteries run down. Next, we have here the current. For the current, we use here the we relate the amount of water flowing through the hose from the tank as the current. So how fast does the water comes out from the hose? So the faster the movement of the water, the higher the current. Also, without voltage, current will not flow because it is the one that creates pressure. So we measure it through over a period of time. So we use it over time. How fast eh? So we measure current in amperes as you just referred as amps. An ampere is defined as 6.241 times 10 raised to positive 18 electrons or 1 coulomb per second passing through a point. We use the symbol letter I. So you can check its meaning why we use letter I. You can do your homework if you want to search for it or do your own research why it is letter I for current. If it is the word current starts with letter C and the word ampere starts with letter A for the symbol. But for the unit, we use capital letter A as amps. And then we can add prefixes such as milli, kilo, micro, nano, and so far and so on. So assuming we have two tanks from, for example, one tank, each tank has the same amount of water, but one of the hoses is narrower than the hose on the other. So what happens that one of the hoses is uh, flows faster. So when the water begins to flow, the flow of the rate of the water in the tank with the narrower hose will be less than the flow rate of the water in the wider hose. So that means the thinner the passage to the to the to the pipe, the slower the water goes. We can compare it to the thickness of the wire. For example, your copper wire. The thicker the wire, sa Tagalog mas makapal, less resistance, faster current, higher current. But if it is thinner, mas manipis, that means lower it can only handle lower currents and it has higher resistance. Since it has higher resistance, it consumes a lot more power compared to thicker wires or yung mas makapal. So in Tagalog, mas magastos yung maliliit na, mas manipis na wire. Although yes, mas mura sila. Kaya that's the backlog of having thicker wire. Okay, mas mahal, mas magastos bumili ng thicker wire. So, since we already have here the thickness of the wire, we can now discuss what is resistance. For the resistance, we can learn it as the host width. So, mas makapal or the thickness or the thinner depends on its resistance. For example, if the material has thicker wire, for example, it has lesser resistance and thinner wire is more resistance. So we measure it as the Greek letter ohm, or we pronounce it as ohms, ohm, in honor of the scientist George Simon Ohm. So, how do we define Ohm's law? Ohm's law is the proportionality of the current and voltage and inversely proportional to the resistance. That means that if you increase the voltage, you also increase the current. But if you increase the resistance, you decrease the voltage and also you decrease the current. But to be exact, when you increase the resistance, you are decreasing the current, resulting to lower voltages. So we can use this triangle formula to compute for the unknown value. So if you're finding for voltage, you multiply current, which is measured in amperes, capital A, to resistance ohms with the Greek letter ohm. And for the voltage, you measure it as capital V. So to find voltage, I times R. To find for the current, we divide voltage over R. So V over R. To find for resistance, we divide V over I. So voltage divided by current. Let's have a sample problem number 1. For example, a small light bulb is connected to a 6 volts battery and draws 2 amperes of current. What is the net resistance of the bulb, meaning the total resistance of the bulb? So first we identify the given. The given are 6 volts, 2 amperes for the current, and we need to identify what needs to be found, which is resistance. So to compute for resistance, we just divide voltage over I. So 6 volts divided by 2 amperes. So 6 divided by 2, we get 3 ohms. All right. Okay, let's proceed. So for the sample problem number 2, a motor with an operating resistance of 32 ohms is connected to a voltage source. The current in the circuit is 1.5 amperes. What is the voltage source in this circuit? So the given are resistance 32 ohms, current is 1.5 amperes, voltage is unknown. So to compute for voltage, we need to use the solution V is equals to I times R. So voltage equals to 1.5 amperes times 32 ohms. So we get 48 volts. All right. Okay, next. Determine the amount of current going through a 50 ohms resistor with a voltage of 120 volts. So the given R is 50 ohms, voltage is 120 volts, I is unknown. So the solution is I is equals to V over R. So we divide 120 volts to 50 ohms. So 120 divided by 50, we get a current of 2.4 amperes. Alright. Next, let's have now the Joules law. So what is this Joules law? Most of the time, Joules law is being associated to Ohm's law. So in some references, they just input Joules law to find for power, but without the credit to James Prescott Joule, who first discovered the mathematical relationship between power dissipation or the power consumption, sa Tagalog, yung nakukonsumong kuryente, and current through a resistance. This discovery was published in 1841, followed the form of the last equation, P is equals to I squared R, and is properly known as Joule's law. However, these power equations are so commonly associated with Ohm's law, equations relating to voltage. Kagaya nga, they are frequently credited to Ohm. So let's have an overview. So these are the formulas used for Joules law, we have here P is equals to I squared times R. We can also use P is equals to IE. E can stand for electromotive force, or also known as your voltage, or P is equals to E squared over R. So how do we define power? Electric power is the rate in which per unit time at which electrical energy is transferred by an electric circuit. So the unit for power that we will use is watt, in honor of James Watt, which is 1 joules per second. So watts, wattage. So electric power is usually produced by electric generators but can also be supplied by sources such as electric batteries. It is usually applied to businesses and homes as domestic mains electricity by the electric power industry through an electric power grid. So we have here resistive circuits. So we just use it, the formula for Joules law. P is power dissipated, I is current, V is voltage, R is electrical resistance. So we can use these three triangle formulas to find for the unknown quantities. For example, if we were to find for voltage given power and resistance, so we can multiply power times resistance. If we need to find for resistance given the voltage and the power, you just need to use voltage squared all over P. Again, for the voltage, if you were to use V squared, for example, given power, given in ohms, after you multiply it, that is not the final answer. You need also to give the square root of V squared. How about this one? We have here P I V. So if we're to compute power, we multiply current and voltage. If we're to compute the current, we divide P over V. If we were to compute for voltage, we divide P over I. For the last one, cross triangle formula, we have here P, I squared, and R. If we were to compute for power or wattage, we just need to know the current and the resistance. So I squared times R. If we were to compute for so for the current, we need to get the square root of the quotient of P and R. So P over R, and when you find P divided by R and then gets it square root. If we were to compute for R, you just need to divide P over I squared. Okay, let's proceed with the example problem. So we have here for sample problem 1, given a circuit component as a voltage of 5 volts, so given a circuit component as a voltage of 5 volts and a resistance of 2 ohms, what is the power dissipated? So to compute for power, just need the given, which is 5 volts, resistance, which is 2 ohms, and find the unknown value, which is power. To compute for that, we just need to use the solution or the formula P is equals to V squared over R. So we squared 5, we get 25, times 2, we get 50 watts. Okay, good. Next. The resistance of a resistor is 15 ohms and the current going through the resistor is 4 amperes. What is the power through the resistor? Let's have the given. For the given, we have 4 amperes and 15 ohms. Let's find for the power. For the solution, we just need P is equals to I squared times R. So 4 squared, 4 amperes, 16 times 15, you'll get 240 watts. Next, for the sample problem number 3, we have find the power dissipated in each of these extension cords. Ooh, so we have 2 extension cords. First is an extension cord having a 0.06 ohm resistance through which 5 amperes is flowing, and a second extension cord which is a cheaper cord using thinner wire and with a resistance of 0.3 ohms through which 5 amperes is flowing. So the given is 5 amperes and the resistance is 0.06 ohms. For the second one is 5 amperes and 0.3 ohms. So to compute for that, P I squared times R equals to 5 squared. So that is 25 times 0.06 ohms. You get 1.5 watts. For the second one, we have P is equals to P I squared R equals 5 squared, which is 25 times 0.30 equals to 7.5 watts. So we now know that the cheaper cord consumes more power compared to the extension cord having a lesser resistance. Okay, next, electrical energy. For electrical energy, it is how where a transfer of energy comes from one kind to another. So when power is dissipated, there's a transfer of energy, resulting to what we call a dissipation of heat. Power, as defined, is the rate at which was work done. Mean there's time included. The rate at which energy is transferred. If we want to calculate the total amount of energy, we need to multiply the rate of energy transfer by the time over which the energy transfer took place. So if that means electrical energy is simply power times time. So P times T. So what is the unit for energy? We measure energy, of course, joules or capital J, power still watts, and time in seconds. Let's have a sample problem. A 30 watts light bulb is left for 8 hours overnight rather. How much energy was wasted? Let's have the given. For the time, we have 8 hours, so we convert 8 hours to seconds, which is you multiply it to 3,600 equals to 28,800 seconds. We have the given 30 watts. Of course, you just need to use the solution given while ago. Energy is equals to P times time. 30 watts times 28,800 seconds. For that, we'll have now 864,000 joules. All right. Let's have the next one. The resistance of the resistor is 27 ohms and the current going through the resistor is 3.3 amperes. What is the power of resistance for the resistor? That's for the first computation. And B, the energy dissipated in 35 seconds. So in order to compute for the energy, we just need to compute first for the power. So to answer that, let's have first the given, which is 3.3 amperes. The 27 ohms for the resistance, and for the time is 35 seconds. So how can we compute for power and energy? So the solution, power is equals to I squared times R, which is 3.3 squared times 27 ohms. You'll get 294.03 watts. And from that wattage, we can now compute for the energy, which is power times time. 294.03 watts times 35. You get now 10,291.05 joules. All right. So let's have now the electrical power industry. Since we already know what are those base electrical quantities, we can now explore more on the reality of what is the electrical power industry here in the Philippines. The electric power industry provides the production and delivery of power in order to give them electricity throughout the country that needs electricity through the use of a grid connection. This grid connection distributes electrical energy to customers and whereas electrical power is generated by a central power stations and then distributed, for example, through the use of a electric power industry. So there's been a gradual trend towards the regulation, meaning that instead of public utility companies or the government handling this thing, the private sector has now the capability to compete or offer consumers a competition to the traditional public utility companies. So these are some electrical power distribution companies here in the Philippines. We have the Meralco or the Manila Rail Company. We have the Beneco or Benguet Electric Cooperative. Of course, it served the majority in the Benguet. The Meralco serves the majority in NCR and all the neighboring cities. For example, here in our place, which is the city of San Jose del Monte, we use the Meralco as our power distributing company, and so far and so on. So these are also some power plants that is being collected. Okay, so they're the ones that produces power, and then those Meralco or alike are the companies that distribute the power. So it is a major thing to know that Meralco is not the one that produces power. Rather, it is the one that is distributing or transmitting power. All right. So let's proceed. So there are about 150 electric power distribution companies in the Philippines. So it differs from Luzon. We have Mindanao. In Luzon, we have 73, and the majority of it comes from Region 3. We have the Visayas part. Okay, so it has 38 power distribution companies, and of course in Mindanao it has 39. Okay, so this data was collected last January 2021. So these are the names of this company. For example, Meralco, which is Manila Electric Company, which included in the NCR. And we have Ifugao, Kalinga, La Union, Ilocos Norte, and so far, and so on. So you can check that out at the website of Department of Energy.gov.ph or DOE.gov.ph. So now, power distributing companies is not included or considered as a public utility operation, which means there are interested parties that do need to secure as congressional franchise. When you say congressional franchise, the Congress doesn't need to file a law for it to operate because it is already now being operated by private sector. So, however, since there's that is a utility, meaning it's a need for uh, modern society, there's a regulatory body that handles such kind of private sector in the Philippines, specifically in power generation, which is also known as the Energy Regulatory Commission. They're the ones that issue a certificate of compliance to interested parties to ensure that the standards set forth in electric power industry Reform Act of 2001, which is also known as EPIRA, to be followed. The ERCR is the one to respond for to determine if there are any power distributing companies that abusing or also known as anti-competitive behavior, meaning that they uh, rate their uh, let's say price per kilowatt hour depending on their standards. So their ERCR are the one that is maintaining the balance. So, what is now what we call the cost of electricity? Since we use electricity, we must be familiar how does electricity is being computed to our bill or electrical bill. So, electricity is sold through what we call units, in which 1 kilowatt hour. So, a kilowatt hour is simply 1 hour of 1,000 watts or 1 kilowatts. Using this, you can work out exactly how much electricity different appliances will use and how much this will cost you. So cost or C, energy, and to find for the cost, you just need to know the price. For example, so E times price to compute for the cost. We have a sample problem. How much does it cost to run a 900 watts microwave oven for 2.5 minutes if the cost of electricity is 61.6 centavos per kilowatt hour? So this is only an example. For example, wattage must be computed to kilowatt per hour. So we divided 900 to 1000, you'll get 0.9 kilowatts. Next, for the time, you need to convert it to hours, which is 2.5 minutes divided by 60, you'll get 4.17 times 10 raised to 2 hours. For the solution, you'll now get power times time. So 0.9 kilowatts times 4.17 times 10 raised to negative 2 hours. For that, you'll get 3.75 times 10 to negative 2 kilowatt per hour of energy. And we're not finished yet. We need to compute for the cost. To compute for that, you multiply the energy to time, which is 3.75 times 10 raised to negative 2 kilowatt per hour times 61.6 centavos. You'll get 2.31 centavos. So that is now the cost of using a 900 watts microwave for 2.5 minutes, assuming that the kilowatts per hour is 61 peso, 61.6 centavos. So let's have some business model of a famous convenience store. So as you can see, we have your 7-Eleven. This video is not sponsored. I hope so, but it is not. Okay. So for example, they use a charging station. This charging station can be used in wherein you need to uh, input 5 peso coin that will give your cell phone a charge of 5 minutes. Okay. For every 1 minute, we're assuming your cell phone gets 3% charge. So how your battery is fully low bat, for example. So in order to fully charge it, for example, to get a 100% charge, you need at least 33.3 minutes. So how much does it cost? So if for every 5 minutes, you get you need to use 5 pesos, that means you need to multiply to 7, meaning 7. Okay, 5 times 7, you'll now use 35 pesos. So in just to charge your phone, they are uh let's say getting 35 pesos from you for your cell phone to charge. But how much does it cost really? Okay, for example, a typical one, your charger is 12 watts. Okay, to identify your wattage of your cell phone, you can try it on your own. Find the voltage and the current. Here, we just assume that the voltage is, let's say, 5 volts and 2.4 amperes, I think, or 2.1. So we use 12 watts. And we use it for 33 minutes always to charge it to 100%. Now, last January 2021, the kilowatt per hour is 8.7497 pesos. So how can we compute it? We just need to compute the wattage, which is 12 watts to kilowatts. You divide it to 1,000, you'll get 0.012 kilowatts. Time 33.3 minutes divided by 60, which is 0.555 hours. You now have solution of energy, which is power times time. So 0.012 kilowatts times 0.55 hours, you'll get 6.66 times 10 raised to negative 3 kilowatts per hour, or 0.00666 kilowatts per hour. Just multiply it per kilowatt hour, you'll now get 0.058273002 pesos, or also 0.06 pesos. Compare it when you charge your phone to your house and you could charge your phone to 7-Eleven. Just look at the difference. 35 pesos versus 0.06 pesos. So, lesson, bring your own power bank if you're going to go low bat. Okay. Anyways, jokes apart, thank you very much for seeing in this lesson. I've learned a lot po. So if you have any more questions, just proceed to ask. Don't hesitate to ask me. Message me in my new account or feel free to inquire me. Thank you very much. Thank you for watching.